I'm here with Leslie Brooks, a longtime leader in QA automation. Leslie has a degree in math and computer science and a strong background in statistics, which will come in handy when we talk about data science and machine learning later. Although he's written a lot of code, his career has been almost all in QA. Leslie loves to automate testing and thinks that manual testing is boring. When he's not writing code or learning new technologies or modifying hardware, he likes to have friends over for dinner and a movie, presumably less so than a year and a half ago. COVID. All right. Leslie, we're going to get to the main topic of our conversation, which is going deep on BDD for data science and machine learning kind of projects. But before we do, I want to talk more generally about your experience with BDD because I think it's interesting in a lot of ways and not the typical examples you see in the books and tutorials. So let's back up to tell us about how you got into BDD to begin with.
I've always tried to find better ways to test. And for me, that particularly meant better ways to automate. And I've seen too many test automation projects that were technically a success. At the end of the day, they delivered some kind of test automation, but they were business failures. They just really didn't deliver a lot of value because the maintenance cost on the automation was so high that you're just really not helping the business a lot. And I didn't like that, but didn't know how to do any better. So in my researching and looking, I heard about this thing called BDD, and the first tool that I found referred to was something from ThoughtWorks called Twist, and looked at that, but realized it wasn't being maintained, and so then I found Cucumber. And the first book that I read, once I decided this sounds interesting, and I think I began to see how it could help. So I got Specification by Example, Goiko Adzik, and that was a real eye-opener. At that point, I went, okay, I'm beginning to understand this. And then, of course, I found the Cucumber for Java book and read that one.
What's that book?
Absolutely, the folks from Cucumber Limited. Mm-hmm. And then I did a proof of concept. And when we did our proof of concept, and this is something I tell people when I teach the class, when we did our proof of concept, I wrote bad Gherkin. And I tell people, the first time you write Gherkin, you're going to write bad Gherkin. All of us do. and after I was done, I looked at it, and I said, I don't think this is right. I don't know why it's not right, but I don't think it's right. And so I went back and reread 3 or 4 chapters in Specification by Example and went, aha, it's not right because we're violating this principle and this principle and this principle. And I went back the next day and we rewrote those scenarios. And when we wrote it properly, we took 52 manual test cases and collapsed them into 17 scenario outlines. Far, far easier to understand than 52 very, very complex manual test cases. So that was when I saw this really can make a difference. It really can do what some people are claiming it can do. And at that point, I was like, we've got to do this.
So how long ago was this first proof of concept you did with Cucumber?
Oh, gosh, that was 7 years ago, maybe 7 or 8, maybe even. It's been a while.
Okay. So as you've been through more cycles of this with different teams, where has BDD and Cucumber made the biggest difference for them? What patterns are you seeing there?
The biggest impact that I'm seeing is from a QA perspective. from an organizational perspective, the impact is huge, and there are a lot of people who can speak to that. Simon Powers has a very good blog, not a blog, but a podcast on the Cucumber Limited, now Smart Bear website, talking about his experience at BNP Paribas and detailing the metrics of the really big impact on the development organization. But from a QA perspective, the biggest impact that I have seen, there are two: maintenance cost. This, if you do it right, it really, really drives down maintenance cost. So on one website that when I came in, it had already been automated. The automation code was being maintained and updated every sprint or every release. And we were using 8 automation engineers to maintain and update that code. And we rewrote everything using specification by example, BDD, and good clean code underneath. And instead of using 8 automation engineers, we were using 1.5 automation engineers to maintain and update all of the same tests for the same website. But we were delivering those tests 2 or 3 days after the developers gave us the code, rather than one release behind the developers. So
but you were still trailing development.
We were, but only because we didn't have an environment in which the developers didn't have an environment in which we could run the tests. They did not have a complete environment. So that was an organizational issue that we needed to resolve. But
so this isn't what I expected. When you were talking about maintainability being better with BDD, I've experienced that as it's really test first versus trailing automation that changed the maintainability of it. It sounds like you have more going on there. What is it that made these tests more maintainable if they were still coming after the development?
That was one website. Another website where they did have an environment in which we could test, we were delivering the automation to the developers while they were writing the code. And of course, that is a big benefit too. But as far as driving down the maintenance cost, back in Programming 101, our professors taught us to make the upper layers of your program as abstract as possible and push the implementation details as far down as you can push them. And by doing that, you're going to make your programs easier to modify, more maintainable. And when we do SBE properly, first of all, we begin by creating a ubiquitous language, a language in which the product owner, the business analysts, the developers, and the QAs can all communicate unambiguously and talk about requirements and business purpose. And when we do that, that ubiquitous language becomes a domain-specific language, a DSL, in which we can write statements of business purpose for our business. And those statements of business purpose, those requirements are abstract. And then when we automate, the top layer of our program is actually our requirements. They're a programming language. So they're abstract. The upper layer of our program is very abstract. And that can lead to a lot of code reuse. It encourages us, it doesn't force us to write clean code underneath. We've started with a very abstract upper layer. The step definitions underneath that, if we keep them clean so that the only thing they do is call high-level methods, there's no business logic built into the step definitions, then we're pushing the implementation details further down. And then our high-level methods underneath our step definitions, they call helper methods that actually have the implementation details. Now we've got a very, very clean automation architecture. We're getting enormous code reuse. And code reuse reduces maintenance costs.
Mm-hmm. So then changes in one place.
Changes in one place, exactly. One of the things that was just killing us on that website where we were using 8 people to maintain it was that there was so much duplicated code. And you change it in one place, and then you have to go find the 6 or 16 or 25 other places where either that code or almost identical code exists that you have to also change. And it was incredibly painful and costly.
What is it about the BDD tools like Cucumber that make it easier or more natural to end up with that kind of architecture? Because you could code that in almost any set of tools where you're at least hand coding tests, not record playback tools, but any automation framework, you could end up with that kind of well-factored code.
You could
push the details down. But in what way does something like Cucumber make it easier to do the right thing?
Because you're beginning with such an abstract, clean description at the top layer. So when you start clean, really, really clean at the top, it makes it easier to stay clean as you go down. You've got a statement of Gherkin, a line of Gherkin, you've got a step definition. And that step definition is at most maybe 3 lines of code. And it calls 1 or 2 high-level methods. And by keeping that discipline, by maintaining that discipline, you are forcing yourself to push the implementation details further down. And you just wind up with a really, really clean architecture.
It sounds like the good Gherkin is pretty critical then to nudge you in the right direction for that.
Yes, it is critical. And as I said earlier, the first time I wrote Gherkin, I wrote bad Gherkin. And in the classes that I've taught, I have seen that every single time. And I just tell my students, hey, the first time you write Gherkin, you will write bad Gherkin. Look at me. I'm raising my hand. The first time I did it, I wrote bad Gherkin.
First time you write anything, writing is editing.
Yeah,
so even now, I invite people to write bad scenarios to start.
Oh, okay.
Let's edit it into good ones instead of trying to write the perfect ones to begin with.
That's an interesting approach. Not one I've tried, but I'll have to think about that.
I discovered that from writing the book, actually, when that was the first time I realized I couldn't do a first draft that was a final draft. In school, I could always just write straight to a final draft. And then the scale of the book was so big that was no longer possible. And in the course of doing that, I realized, that's how you end up with good Gherkin. Gherkin's just nonfiction writing in a pidgin language, but it's still nonfiction writing.
And even with our teams and a lot of training, when we began writing Gherkin, we still wrote bad Gherkin. It wasn't as bad, not nearly as bad as the first Gherkin I wrote, because I was right there with them the entire time. And so I was reminding them of what I had taught and saying, remember what I said about, and so we would correct that before we ever really implemented it. But even so, there were a lot of instances where we said things that meant the same thing, but we said them different ways. And we wrote things that meant almost the same thing, but we wrote them very differently. Rather than writing them the exact same words with just 1 word difference, there would be 5 words different. And all of those things make it harder to use your ubiquitous language as a DSL, and harder to automate your DSL, and harder to maintain it. And we went back and redid a lot of that to correct that, to find things where it meant almost the same thing, but we had said it different ways. And so, yeah, there's a great deal more to it than simply writing given, when, then. You look at it and you go, this is easy. I just write given, when, then, and I've got a requirement and I've got a test case. And I go, well, it's a little harder than that. You've got to really, really think about the language that you're using. You've got to ask the product owner, what do you mean when you use that word? Do we need to write a definition for that word and stick it up here between feature and background? I like to have a definitions section there where we define terms that are specific to this domain or that are used in a very precise way so that people can come back and read our requirements, our documentation, and they go, I'm not certain that I understand what a minimum rank sum means. Let me go find the definition of that.
Other than consistency, like using one phrase to mean one thing and small differences to mean small differences in reality, what else do you look for that makes you say that's good and that's not in Gherkin?
Well, of course, there are 1,000 things that you and I both know to teach. If your scenarios are more than 5-6 lines long, that begins to be a requirement smell. You go, are you writing a requirement, or are you writing a script, or are you including implementation details that shouldn't be in there? They're not part of the business purpose. The product owner probably doesn't care on which page of the website you began. What they care about is that the tax is calculated properly when you make a purchase. Calculating the tax properly doesn't matter where you started. So there are 1,000 things like that people can learn from reading your book, Behavior-Driven Development with Cucumber.
Thanks for the plug there. I appreciate that.
It's a great book. I really like it. I mean, I've mentioned others too, but no, it's a really good book.
One of the nice things about BDD right now is that pretty much all the books around BDD, specification by example, and Cucumber are pretty good to great. You're not likely to end up with a book that sends you in the wrong direction.
Yeah, that's true. So the way that I know when we've gotten really good Gherkin, a really good domain-specific language, a really good ubiquitous language, is when we get to the point where we can write a new requirement using existing Gherkin. If we can take existing Gherkin and write a new requirement using it, then I know that our language is working well. And
when you say new requirement, you mean changing a value or something in there?
Changing values, changing from dependent variable to independent variable in the Gherkin. And internally, our automation simply treats dependent, independent, function, whatever the word is, as a capture group in the regular expression, and pulls that out, passes it down to some high-level method that passes it down to some helper method that calls the API that you're actually testing, and it just works. When you get to that point, you discover that you can write new requirements, and you do not have to write any Python or any Java for those requirements to be automated tests. You write the requirement, and it runs because you've built up enough step definitions down there and enough high-level methods down there, and you can write this new requirement reusing existing Gherkin. It's already automated. You just run it. we've actually gotten to the point on some of the projects I've worked on where we and the product owner and the developer will be talking about something and we'll go, well, wait a second, what should happen if we do that? And somebody says, well, what happens right now if we do that? And one of us goes, let's write a requirement and see. And literally we write the requirement, run it. There's nothing to automate, no code to write. We just write the requirement and click run. And the requirement comes back and it either passes or fails. It fails. It comes back green or it comes back red. And we go, oh, that's what the application does when we do that.
Yeah.
It's a delightful thing when you can do that. And when the developers realize how that works, the developers just go, oh my gosh.
You're describing a system that's progressively cheaper to maintain and extend, not just holding the cost steady or not increasing very fast, which is probably what we're used to as what would be good for maintenance. Mm-hmm. Of course, the system gets harder to deal with as it gets bigger, but not too much harder. But you're talking about a system getting easier to deal with as it gets bigger.
Easier per requirement by far. Yeah. Yes, you can literally write new requirements that require zero code. And as developers, we should always try to avoid writing code, because every line of code that we do not write is a line of code that we do not have to maintain, and that drives down our maintenance costs. It's a strange way of saying it, right, but it's a true thing. You know, as a developer, I should try to not write code.
Right. That's principle 10 in the Agile Manifesto, right? Simplicity is the art of maximizing work not done.
Maximizing the value of work not done. So we want to maximize the value of the code that we don't have to write. Start back with your question again, because there was someplace else I wanted to go with that. You were talking about, reducing the maintenance cost, not just so that it goes up gradually, but so that your value is going up much faster than the maintenance cost.
Right, like cost per unit of change.
Yes,
has gone down in this.
Yes. The other place that we can do that, which is an incredible benefit for QA, is that if you are disciplined, if you write your requirements well, and then you write clean code underneath that, you can reuse automation across interfaces. And that's something that has never been done. I mean, traditionally, it was just you wrote automation for the API, and you started from scratch when you wanted to write automation for the website. And then you started from scratch again when you wanted to automate testing of the iOS app. And then you started from scratch again when you wanted to automate testing of the Android app. Here, if you do this well, you're actually reusing a big chunk of code across all of those interfaces. So you automate the API, because that's what the developers, have running first. And then you go to automate the website, and half of your code is written.
You're talking step definitions or helper.
Step definitions classes. And your high-level methods.
And you're plugging new ones in. And people talk about this, but I've almost never seen that done in practice. But you've actually done this before?
We've done it.
Nice.
A system that I worked on.
Gherkin, if you can get away with that.
A system that I worked on had an internal website, an external website, iOS and Android apps, API, a Salesforce API internally, a Salesforce GUI internally. I don't think we ever automated that one, though. And another API that went and talked to some hardware, and a UI on the hardware. I don't know how many interfaces that is at this point, but we were reusing code across all of those. And not only reusing code, but we could actually switch interfaces at runtime. So I could launch my program, my automation test program, and select my interfaces and say, I want to test beginning at the consumer website, and I want to do my verifications through the API and run it. And then I could flip it around, run the exact same automation program, and just pick and say, I want to begin my testing. I want to test from the API and do my verifications through the Android app. Same program, reusing code, runs. You can't do that any other way.
Yeah. And
that really drives down maintenance cost.
Right. Is it always better, or have you encountered times where BDD doesn't drive down maintenance cost? And what were the differences?
Well, certainly there are things where automation generally does not drive down maintenance costs, or is just catastrophically difficult to do. When you're dealing with a physical interface, something that has switches and knobs, and you have to physically manipulate those. I have seen someone program a robot arm to do it.
I can imagine how that would keep your costs down. If you're going to turn that knob enough times, the robot's worth it.
Yeah. But certainly if your requirements are going to change, anytime you have a program that is either going to change very, very frequently, or you have a program that is going to be written once and never changed, then automation doesn't make a lot of sense generally. We can talk about the test pyramid and, do 80% of your testing below the UI and only, 10 or 20% through the UI. But if the program changes dramatically every week, then, maybe automation isn't the best approach.
Right, so you're not getting the repetition for.
And if you do it poorly,
right.
If you write your Gherkin poorly, then your maintenance is, your automation is not going to deliver value. If you write bad Gherkin, or you do not write clean code underneath, this methodology doesn't force us to write clean code. It doesn't force us to drive down our maintenance costs. It encourages it.
Other than maintainability, what benefits have you seen on the teams that you've been part of?
Well, the benefit for the organization is the communication. The product owner and the product owner and the developer and the QA have a much, much better common understanding of what it is they're going to deliver. The product owner has much greater confidence that the developers are actually going to deliver what they want. I talk about two types of bugs, big B bugs and little b bugs. And the big B bugs are the ones where the code does exactly what the developer intended. It's just not what the customer wanted. And those are very easy to find. You deliver the code, and the next day the customer goes back and goes, "What's this? This isn't what I asked for." Fixing them could be very challenging because you may be dealing with architectural changes at that point, a lot of cost. The little b bugs are the ones where the code does not do what the developer intended. And those can be difficult to find, and some of them can be very difficult to fix, like, race conditions, very challenging to find. But the really, really expensive ones are the big B bugs. And specification by example, because it creates that common understanding between all of the people involved, all the groups involved, really, really reduces the risk of having a big B bug. That for the organization is just an immense value. And then, of course,
really what our QA practices have been optimized for, right?
That is not what our QA practices have been. Oh, no.
They're good at finding the unintended ones.
Yes.
Because they're testing to that same spec that was misunderstood to begin with.
Exactly. So the developer, the QA people go to the developers and ask, well, why is it working like this? Well, that's because the product owner asked for that. Oh, okay. And so we go write our test case and we test it and we go, yes, it passes. And then we release it and the product owner goes, what is this? I didn't ask for this.
That reminds me of a story my dad used to tell me. He was also a developer for his career, and he talked about one place he worked where one of the bug close statuses they had was works as implemented.
Works as implemented, yeah.
It does what it does. Yeah.
It doesn't deliver value for the customer. Well,
We don't talk about that.
Gosh, I'll have to remember that one. Works as implemented. So the common understanding is huge. That saves so much development effort. Going back to Simon Powers and BNP Paribas, he documented a 40% reduction in developer cost. They went from spending 40% of their time fixing defects to essentially, 0% of their time fixing defects. And that wasn't overnight. Huge. It's huge. It wasn't overnight. It was, it was after 9 months of training, coaching, sitting there with and, showing and practicing and it took time, but very big. And the other thing, of course, is when we are routinely delivering the automation in Sprint, the developers, come to the point where they just depend on QA. They're like, as soon as I have this code running, I'm going to be able to run tests on it. And the value to them is immense. And the other value, of course, is the confidence that it gives the developers that they can go in and change code without breaking something.
Yeah, that's so important and underappreciated, I think. The amount of cognitive load and delays that come from a developer not being able to feel safe changing the system. So you've got to be extra careful and slow about what you're doing, and then you break something you didn't expect. That's huge.
Yep.
For your teams and teams you've worked with on this, what has been particularly hard for them to adopt or change around BDD?
The hardest things have been the learning curve around Gherkin itself, particularly for the QA teams. The QA teams are so accustomed. They're good at writing scripts. They think in terms of test scripts, and Gherkin is not for writing test scripts. Aslak, in one of his blog posts, for those who don't know, Aslak Helisoy, the developer, the creator of Cucumber, in one of his blog posts said, if you think that Cucumber is a good testing tool, please keep reading because you're wrong. And the QA people are so good at writing scripts, and you give them Cucumber and they go, ooh, a powerful scripting tool.
Right.
And you have to re-educate them. It's not about writing scripts, it's about writing requirements. So the first hurdle that I always see is learning how to write good Gherkin, good requirements. Learning to talk about purpose rather than implementation. That's probably the first hurdle. And then learning what concrete really means. That's another hurdle. Well, specification by example, or BDD, says that requirements you have a statement of business purpose, a title for a scenario, and it should state a business rule. And then the Gherkin illustrates that business rule. And the examples illustrate specific instances of how that Gherkin is applied. And they have to be concrete. You cannot say more than 5 because, well, what is more than 5? What is the developer going to write? What is the developer going to write to get more than 5? Do they write 6? Do they write, 5.1? 5.0000001? What is more than 5? And an example of that where BDD was so valuable and concrete was so valuable. I was working with some business analysts and product owner who were learning this. They'd been through my class, but they were practicing for the first time in a real project. And we were talking about transmitting driving data from a vehicle back to a central database so that if you opted in, your insurance company could see how you drove and could give you an appropriate discount or no discount, as the case may be, on your insurance. And one of the things the insurance companies wanted to know was, do you drive between, say, 1 a.m. and 4 a.m. in the morning? Because they have determined that driving at those times is more dangerous than driving at 1 to 4 p.m. It's dark, you're tired, accidents are more likely. Mm-hmm. And they also wanted to know how frequently you exceeded, 60 miles an hour or something like that. So the product owner said, okay, so we need a requirement that says, given I'm going less than 60 miles an hour, when I drive more than 60 miles an hour, then a timer will be started to time how long I'm driving over 60. And I said, okay, but more than 60, less than 60, those are not concrete. What numbers do we want to use? How precisely do we measure speed?
You cannot get away with driving 60 indefinitely.
The answer was some absurd precision. It was like 0.01 mile per hour or something. Wow. And yeah, it was. I mean,
I didn't even know cars could.
I don't think they can. I think that's just simply what was reported.
Okay.
And so one of the developers, I think, so somebody said, well, okay, so 60.00 and 60.01. And one of the developers said, but if you set the cruise control on 60 and you're driving through hills, you're going to be constantly going above and below 60. And every one of those transitions generates a new record of they're driving above 60. Do you want to transmit all of those records to the database? And the product owner goes, oh, we'd be paying a fortune for airtime for transmitting all that data. So no, I definitely don't want to do that. And so then we got into a discussion of, okay, then what are the limits that we set? So BDD...
That's a whole different conversation. Where everybody's nodding along with the below 60, above 60, and then the concrete example changed it.
The concrete example absolutely changed it. And that's one of the things that people have to learn is that examples must be concrete. More than 60 is not concrete. So, yeah, there were some real eye-openers in that meeting. People went, whoa. And they also understood at that point, this is what concrete means.
Mm-hmm. I imagine you're like me and feel like a broken record going, what's an example of that? What's an example of that?
But thinking of it another way, one of the huge benefits to developers of concrete examples, every row in an examples table, ideally, is it requires a specific test or a line of code from the developer. Because every one of those examples in an examples table, internally for the programmer, it's a boundary condition. Or you have one that's not a boundary condition, a value inside the bounds. But essentially, every one of those is a boundary condition, and it means the developer has to write a line of code. So when you're writing,
what examples are meaningful?
Yes, and your QAs can absolutely help you with that, because QAs are very accustomed to thinking in terms of boundary conditions. Mm-hmm. Are there any other possible outcomes from these preconditions? Oh yeah, well if it's, if the bill is paid more than 30 days late, then it's this amount of penalty. Okay, so 30 days is important, and that means 29 days is important. At 29 days, it's only a 5% penalty, and at 30 days, it's a 7% penalty or whatever. And the QAs think of that, and they put them in the examples table, and then the developers don't have to guess, and they're far less likely to miss something.
I'm getting the sense you like scenario outlines a whole lot more than I do.
Scenario outlines are extremely valuable, but certainly scenarios, there are plenty of instances where just writing a single scenario is very valuable. Scenario outlines, when you have a business rule that has many complex variations, scenario outlines can really add clarity there, where you might have to write 5 or 8 scenarios. You write a single scenario outline, and it's far easier to comprehend than 5 or 6 separate scenarios.
I've seen premature scenario outlines as something that leads into bad Gherkin a lot of times. Like, you end up writing from a developer or tester perspective instead of a business perspective. How do you ensure that you have good expressive business requirements in the Gherkin and still exploit the benefits of scenario outlines there?
I think the best way to do that is you're including the product owner in these conversations. So the product owner should be the one who is stating the business rule. Here's the business rule, the title of your scenario or the title of your scenario outline. Now let's write Gherkin that illustrates that. Are there multiple examples of that? Oh yes, there's several examples. If it's 30 days, if it's 15 days, if it, and so then you go, okay, we've got a requirement, but we've got a multiple, possibilities here. Let's make it a scenario outline. But I think including the product owner, making certain that it's language that they use that is clear to them, starting with that, you can avoid requirements that are that look like test cases instead of requirements.
All right, I think we've laid a good foundation for the topic that originally made me want to have this conversation with you today, which is you've been working on data science, machine learning kind of stuff lately, which I imagine creates some unique challenges for BDD. Can you talk about that a bit?
Well, it does. First of all, probably most QA people don't have a strong statistics background or maybe even a math background. And that's just almost essential for this type of work, because data science, machine learning, heavy use of statistics. I mean, I have a good background in math and statistics, and I'm constantly looking things up and going, okay, so what exactly is a Savitsky-Golay filter, and how does it work? And yeah. Trust me, I lost me several times too. So, but then the other thing is that a lot of data science and machine learning internally uses a random number generator, because or it uses things that we can't find explanations for. We can't explain how neural networks work, how the weights in the network produce certain outcomes for certain inputs. There's been some work on that quite recently. Some folks from Google published a paper on essentially on understanding why a neural network is producing a certain output. The example was identifying zebras. So you show the neural network a picture and it says, this is a zebra, that's a cat. And so you then give it pictures that consist of things that it might use as keys to determine that it's looking at a zebra. For example, you might just give it a field of grass, because all the pictures of zebras that you've shown it are out on the savannah.
Oh, so it's not even the zebra.
No, it's not even the zebra. It's the grass. You give it a field of grass and you ask it, what is your confidence level that this is a zebra? And if it comes back and says, I've got a 25% confidence that that's a zebra, you go, oh man, you're looking at the grass, not the zebra. Or you give it a picture of nothing but vertical stripes, maybe even colored stripes instead of black and white stripes. And you ask it, what's your confidence that this is a zebra? And if it comes back and says, I've got about a 30% confidence that that's a zebra, you go, aha, it's looking at stripes. Well, that's a good thing. So there's been some recent work on that, and that's helpful. But a lot of the statistical algorithms that are used in data science internally use a random number generator. For example, optimizers. You give it a function. Well, I should back up. Data science uses statistical techniques and it uses random number generators because there's no way to get an exact answer, or at least we don't know of any way to get an exact answer in a reasonable amount of time. Because if you're dealing with a problem that has 1,000 variables and nonlinear relationships among those variables, then trying to calculate an exact answer is infeasible. So you fall back and you say, if I can't get an exact answer, how do I get a good answer? And you go to statistical techniques. And some of those statistical techniques, for example, might pick 100 points at random in this 1,000-dimensional variable space and calculate the value of your function at all 100 of those randomly chosen points, and then iterate from there depending on how good an answer it got at each of those points. And that's very, very different from a website where, or an API where if we give it these inputs, we know exactly what output is going to happen. So the ways you get around that in working with data science, you can write requirements about probabilities or outcomes that are statistical in nature. You can say, if I give it these inputs and I ask it to optimize, then the result that it gives me will be better than the result it started with and you can give it a measure. You can say it'll be at least twice as good as where it started. Or, and this is something that, again, is a little odd for QA, but if you have the ability to reach inside the data science application and control the starting seed for its random number generator, then the answers become deterministic. They're still incredibly complex, but they are deterministic at that point.
So you can write scenarios about those.
You can write scenarios about those, absolutely. The biggest place, though, and the place where it's easiest to apply BDD to data science is all data science applications go through what's called the ETL process up front. And ETL means extract, go get the data from its original source, transform, clean it, make some modifications to it, and load. ETL, extract, transform, load. Load it into a database, a data lake, an Elasticsearch, where you can then query it and perform statistics on it. When you're collecting data from hundreds of different sources, you are absolutely guaranteed that it's going to be dirty. This source gives you back the the names of the sensors in all caps. And this other source gives you back the names of the sensors in caps and lowercase. And this other data source used to give them to you in all caps, but last month they changed it. And now it's giving it, and 6 months ago they changed the names of the sensors, and it just goes on. There's thousands of ways that data is dirty. So this exchange, transform, load process has to take in that dirty data and clean it before you give it to the data science or machine learning algorithms. Else you're gonna get absurd answers. And you can definitely write requirements, clear scenarios about this ETL process. If I get in this data and this sensor has a value yesterday and a value 2 days ago and a value today, but it doesn't have a value for yesterday, then I want you to calculate a value for yesterday using this algorithm. If there's no value for yesterday, I want you to drop in a 0. If there's no value for yesterday, I want you to strike that line from the data, delete it. If there's no value for yesterday, I want you to substitute in NaN, N-A-N, not a number. Data science applications know how to work with not a number.
So this is a different kind of thing than we would normally test from a Cucumber scenario on a customer-facing product. We would think about those as those are internal developer-facing concerns. Here, I can see how you'd want to isolate those and express business concerns about those things.
It's hugely important, because if you get the ETL process wrong, then you're not going to get good results out of your data science. You've spent all this time and money sucking in data from hundreds of sources, and you've built these huge clusters on AWS, and you've crunched tens of thousands of calculations, and the answer comes back and it goes
Have you seen anybody run tests like this in production? It seems like there's something here that to you flagging that the actual data has changed and helping you debug when something doesn't work properly. But I imagine that requires some pretty different design in the tests for that application.
I've never seen that. That's a fascinating thought. and one that I'm going to have to think about. But no, I've never seen that done.
Okay, so you get tests around the ETL process because it's deterministic, and you're at least starting with known data. You can go non-random on seeds and get that deterministic. And you can do these statistical kind of assertions. What else looks different for data, machine learning sorts of things with BDD?
I think those are the big items. Obviously there's a huge domain of knowledge that we have to learn, like Savitsky-Golay filters or, all of those things that data science uses and that we have to be able to converse about. I'm by no means an authority on a Savitsky-Golay filter, but I can at least look at it and go, okay, yeah, I remember what the parameters are going into it, and I know how they're used, and yes, so we can sit down and write requirements about it. You're the expert. You tell me. I can help you express them.
Right. I'm curious about the human side of this. Many of my interactions with data science teams around even general agile stuff has bumped into a lot of we're different, this doesn't apply to us, leave us alone, let us be a black box to the rest of the teams. I wonder how much you've encountered.
I've certainly seen that. I've certainly seen that, but when I show them how it does apply and how we can write very precise and understandable requirements for the things that they're doing, I've seen a big turnaround. I've seen them come back and go, oh, I get this. I understand the value of this because now I can write requirements that the developers can understand. And I now have confidence that when the developers write this code, I'm going to get back what I want. So yes, I've absolutely seen that up front. They're like, no, you can't write requirements for this stuff. It's too complex. And then once we dig into it and show them, they're like, oh, these requirements, they make good sense. This is valuable. So I've certainly seen it.
So you did kind of a what's in it for them.
Oh, absolutely. Absolutely. Anytime you want to introduce a change into an organization, few people jump up and go, let's change.
Yeah, new and shiny. There's a few of those, but not many.
Not many. And so anytime you want to introduce change into an organization, I've found that I always have to explain what is the value. Why should we make this change? And as much as possible, I want to explain what is the value for you and your group. Mm-hmm. Because even though these people, they're conscientious and they're good employees, and they understand that they want the company to benefit, but they kind of want them to benefit more than they care about the company benefiting. So I definitely want to show the data scientists, this is what the value is for you. You're going to be able to have very precise requirements and have confidence that the developers are going to deliver the right thing. And when we have to go back and make changes to that code, you're going to have confidence that the things that we wrote last year still work properly because we've got requirements. We can run the requirements, and the requirements will come back and tell us whether they pass or fail. For the business analysts, there's not a lot of benefit in this. For them, it's just as much work. And I had a group of business analysts who told me this after about 9 months, after they had transitioned from traditional narrative requirements to specification by example. They told me, they said, this isn't any less work. In fact, it may be a little bit more work up front. But once we deliver the requirements, that's the end. There are no phone calls. There are no people stopping at our desk. There are no emails. There are no Slack messages, asking us, what does this mean? And they really liked that. So the business analysts are the group that benefit the least from this. But what they do get out of it is, once they've done it, it's done. They don't have people coming back and asking them questions about it. And they like that. The product owner, of course, huge benefit. I have great deal of confidence that when the developers develop this, there aren't going to be those big B bugs where they wrote great code, great architecture. It just happens to do something different than what I wanted it to do.
It does the wrong thing really well.
It does the wrong thing really, really well. And it's great, clean code, too. There'd be low maintenance cost on it. We just have to throw it away. And
you use confidence all around, and I think that really is the important word here. And I found it something that is hard for many people to even imagine what it would be like to be able to change a system safely, or to be able to know that when you're done and it's correct. That higher level of confidence is so important.
It is.
Experienced.
Yeah. I mean, you can listen to conversations like this. You can read things by Simon Powers or, Aslak's blog, and you can say, I know that there are people who say that you can do this. I've just not seen it, but I want to see it. I'm going to have to try this because I have to see if it's possible. And it is possible. It is really, truly possible. And the developers I've worked with, when they realize that QA is going to routinely and repeatably deliver automated tests to them in Sprint, and that they're going to be able to run all the requirements against a new version of their application whenever they feel like it, whenever they want to, and they're going to be able to know that they've made these changes without breaking something that was there before. Those are happy developers.
Yeah. So that brings me to the last thing I want to ask you before we wrap up here, which is, somebody's listened to this so far and says, okay, I want to get started. What advice do you have for individuals or teams who want to get started with BDD? What should they do or not do?
Seb Rose commented on this just a couple of days ago. He said, I had forgotten your excellent advice. Never, ever Google BDD tutorial or Gherkin tutorial. If you do that, BDD, specification by example, is about where Agile was 10 or maybe even 15 years ago. And you've seen Agile develop. You know what it was like 10 or 15 years ago. There were a lot of companies that were experimenting with it and that were saying, oh, we're Agile. And all they really meant was, we have a Scrum and we deliver something every some number of weeks. We don't know what it is, but we're going to deliver it. And we're Agile. And my response is, no, you're just chaotic and you have some of the trappings of Agile. So there were a lot of companies that were claiming to be Agile and that were really doing it poorly and not seeing good results at all. My favorite being the team that said they were following Agile, and I found out they had 3-month sprints.
How long was it before?
Yeah, right. And
years.
And BDD, specification by example, is like that right now today. There's so many people out there who say that they know it, but they're really just writing scripts. Or they're, including implementation details in their Gherkin, or they're talking about interface, or, all sorts of things that have nothing to do with business purpose. So do not Google BDD tutorial or Gherkin tutorial. It will definitely lead you astray.
It is really hard to write a good small tutorial.
Yeah.
So I feel for the authors of those, and I agree with you. There's a lot of people just trying to make a hello world kind of thing in Cucumber that then shows you the wrong way to do it.
So I'm sure that your website has many useful blog posts and examples and
not very many actually, because it's hard.
Yeah. And of course, cucumber.io, the folks from Cucumber Limited, now part of Smart Bayer. Anything you read there is trustworthy.
Yeah, the docs have gotten so much better over the years. Early on, they suffered from this same tutorials are hard problem. And they would have toy problems in there that weren't representative. Now they're more realistic than they used to be.
Goiko's website, of course.
He's probably writing more quality stuff than anybody else right now on what good Gherkin is. He's got those regular challenges on hard Gherkin problems. I've been enjoying that series.
Yes. And of course, as we've discussed, there are a few really good books. Goiko's book, Specification by Example, your book, you and Paul, Behavior-Driven Development with Cucumber, the Cucumber for Java book, if you're in a Java shop, or the Cucumber book, if you prefer Ruby. And all of those are trustworthy. Great resources. Beyond that, I don't know of anything I can trust.
So then once somebody has picked up a book, what's the next move you would suggest for them?
I really liked what someone I'm working with right now, a product manager in this company, includes some of the role of a business analyst. I suggested that he read your book, and he did, and came back and said, wow, I've learned a lot from that. He said, I think I need to read it 2 or 3 more times to really grasp this. And I would second that. I read Specification by Example until literally it was worn out. I must have read it 5 times or 6 times, because it takes time for this to sink in, and it takes time to unlearn habits that were good back when we first learned. They were the best way we knew to do them 10 years ago, 15 years ago, but they're not the best way now. So I would read it and then reread it. And then I would start, as you said, with something very small. Start with a very small domain, write some Gherkin, and automate it, and then step back and look at it and ask, how clean is this? If I try to extend this, how much work is it going to be? If you discover that you're having to write a new step definition for every scenario that you write, then either you don't have much Gherkin written and automated yet. That's a possibility, first start. Or your Gherkin is all over the place. You're not being consistent in the way in your language. If you were developing Python, you wouldn't want 6 different ways of expressing a loop. You'd want to keep it spare. And same thing in your Gherkin. You need to really think about, what is the minimum number of words that I need in order to accurately express what I want to say here. And that takes practice.
Yeah. Well, Leslie, it's been a pleasure, and I want to thank you for spending the last hour with us. I think this is going to be really valuable for people, not just in data science, but adopting BDD more generally.
I've enjoyed it. Thank you, Richard.